All right, thank you for coming. You start?
Oh, yeah, let's go. So, well, thank you all for coming today. We are a bit late, so sorry about this. We'll try to move forward. So today we'd like to open a discussion with all of you about bringing data analytics to software-defined products, to basically producing software. This is a table of content, so it's going to be a bit about us, speakers, a bit intro about the topic, the motivation, and so on and so forth. So really quick here, so my name is Daniel. I'm not that involved in software-defined products. Indeed, this is my first time at Linaro Connect, so this is a great conference, and thank you for being so welcoming. I'm the CEO of Vitergia, a small startup based here in Madrid. We work remotely. We do development analytics and consultancy on inner source, open source, and other areas. And then I'm wearing a couple of extra hats at the Inner Source Commons Foundation as president and part of the Chaos governing board. It is a working group from the Linux Foundation on development analytics. And Agustin?
My name is Agustin Benito Betancourt, and I'm an independent consultant. And basically, what I'm doing is, or the topic in this talk is bringing the knowledge that Vitergia has in data analytics in open source, bringing it to commercial environments. That's basically my main job.
If you want to learn more about Vitergia, is there the slide? So no worries. Let's move forward.
All right, so our starting point is always, if any of you have gone to a manufacturing facility, hardware, whatever, you see the level of control they have about what's going on. So having all this experience in creating data analytics in open source, and together with my experience in managing teams or working on embedded, and in automotive, the question is, can we have some of that level of control over our production environments when we are dealing with software, especially bundling software and hardware, and especially at scale when we are talking about several hundreds of developers? So that's a question that we are trying to answer by helping companies to get into the data analytics journey. And probably those of you that has been interested in this topic, in productivity or in process performance, there are a couple of frameworks out there that give us already a very, very good start. One of them, probably the most popular one nowadays, is called DORA. Actually, it's running by Google. And then you have others, more modern ones, like DivX. I will talk about these ones. They have in common the leading person that started both of them, which is Nicole Forsgren. And the interesting point about these two is DORA. What DORA has tried to do basically is correlate capabilities if you come from the Agile world, the DevOps world, it's just about practices and methods connected with principles, together correlate them with outcomes. Outcomes being mostly organizational performance through delivery performance and staff well-being, connecting those. DevX is a framework that came out last year. It's very developer-centric. The idea there is that if you improve the developer experience, that has a direct correlation with improving the organizational performance, the delivery performance, again, the well-being. So we already have some frameworks out there, metrics frameworks, that can help us in production environments to understand and improve what is going on at scale. But obviously, like any metric framework, there are some limitations. The first idea that you need to understand is that these frameworks promote the idea of, take the data and measure what's going on in your own production system. But most of the findings are done through sociology. So it's based on surveys. Mm-hmm. And then another interesting fact of these frameworks is that they have been developed mostly in cloud-first environments, not in embedded environments, or not in automotive environments, not in this kind of environments where Testing on hardware is a thing where you have suppliers, where you don't have end-to-end control of everything that is happening, where there is a difference between deployment and release, where maintenance is a very important topic. So, yeah, so I'm giving you an idea of what's out there and some limitations. So we're gonna keep going.
Yeah, and specifically in the space of the journey into data analytics, so we are entering into more complex software-defined products. We are growing in that area. We need to scale. We need to do improvements. Continuous maintenance, et cetera. And ideally, because of these limitations that we've seen in the existing frameworks, we have this motivation that an idea and concept that basically companies should own that analytics journey. So, and why is this? Because if you have data then in complex systems, basically you will be able to have an understanding of moving forward with scalability, moving forward and taking control of the cost, perhaps understanding and having a full understanding end-to-end of the development velocity and others. From an academic perspective, and this might be a good metaphor for the analytics journey, we are still on the left side, on the three first square at the bottom that you can see. Basically, we are still describing the problems and we are still in the diagnostic space. So basically, what has happened and why did it happen, right? So we know why this happened at some point, but a posteriori somehow. So this is happening in the industry, this is happening in academia as well, basically. We are still describing software development is still a creative work. It's still an engineering, probably we are not there yet. We can have that discussion later if you want. And then basically we are entering into the predictive space by having AI, some models, et cetera, et cetera. So this is where we are right now in the analytics journey. With all of this data that is available, either internally or publicly available, then you can start creating and moving forward with some models and so on. So now let's move into examples, real life examples.
So we talked a little bit about the frameworks that are out there. We are providing this message to all the companies we talk to of, hey, this is something that you will need to pay attention to. And now let's see what can we do with data and how data can help us in improving our delivery process. I'm just going to give a couple of examples. So the first idea is you have a process, no matter how complex it is. Let's assume that you have several dozens of teams that create software that goes through several stages of testing and validation. And then finally you release that will get deployed in your hardware. At the end of the day, there are certain characteristics that embedded or automotive at scale has that needs to be taken in consideration. And because it's so complex, at the end of the day, in order to understand your complex system, you need to create models. So here you see an example of a practical description of a process. This is a real one. And then you have, for example, it's not linear. You see that, imagine that you have two suppliers and then you have your teams developing software, right? So it's not a simple linear process, what you have. And then you have to model your process. So you stage it, you separate it in different stages, right? You have several, for example, you have this validation stage, which is very typical in many embedded environments that is not typical in cloud-first environments, for instance. Or this idea of release here that you might, so you are releasing to, for example, an OEM, or you are releasing internally because for liability reasons, you have different companies creating the software, although everything is under the same umbrella. I mean, there are plenty of cases, right? So you model first. This is the kind of thing that that's the first step that we need to do. And why do we need to do that? Because once we have a model, a simple model on structuring stages, we kind of start applying, for example, flow metrics, basic metrics. Some of you might know them as DORA metrics. In fact, they existed a long time before the DORA framework labeled them. But throughput, you can start measuring throughput in your model with time interval lead times, or you can start measuring the stability of your delivery process with time recovery and failure rate. In order to be able to apply these simple metrics to your entire process, you need to model it first. So here is an example, right? That, and then you change things. Your developers start to create some kind of experiments, and they will tell you if locally those experiments resulted in mitigations or in successes, but you can also measure the impact at global scale, which is the hard part always, right? Then another typical example of things we do, by the way, that was on the descriptive side, but if we go to the diagnosis side, imagine that you already have a good description of your system. You have a lot of data related with your teams, with your repositories and your code, with your bugs, with your work packages, depending on the methodology you use. Those could be stories and epics, those could be tasks, those could be actionable objectives, right? Then you have your requirements. You take data from different sources and different tools, you collect it, and then you start visualizing. And then once you have a good description of who you are and what you are doing, you start with diagnosing behaviors. And here is one of them. We know in embedded that our systems are not loosely coupled most of the times. They are not microservices, so there are plenty of dependencies on the code. Then the companies are hierarchical. There are dependencies at organizational level, and then you have many other kind of dependencies. So for instance, we have 3 examples here. The first one here is very typical in environments where there are suppliers. So what we are these are the kind of reports that we do to let others understand how are their suppliers interacting in code. So you have, on one side, organizations and teams. On the other side, you have repositories and code. And also, you have bugs. Think that those are 3 different tools, right, where you need to extract data and process the data, normalize the data. So there is quite a lot of engineering there. So we try to identify here in this case where are the strong dependencies that we were not thinking of. Right? And that affects the performance of your delivery. In this case here, we are analyzing 3 teams, and we want to know it seems to be a bottleneck in a specific subsystem of your product. And what we are trying to identify here is if there are strong dependencies within the team that the architects, for instance, did not think of. Right? So one of the typical analyses we do is we look at who is working on the repos, and then we look at the communications between them to see trends, to find out trends and relationships. And then here, for example, this is typical examples in when we are finding bugs related to specific parts of the code. And what we want to know if there are dependencies between teams working on the same code that are not managed. And several people touching the same files and nobody has ownership, for instance. This is a very common case, right? This is the 3rd one. Okay.
And then moving forward into code review. So these are, so code review, why do we want code review? Maybe you are doing code review, maybe you are not doing code review internally in your company, but ideally it's a good place to extend knowledge all across different developers. You may want to have certain onboarding processes, so code review is typically quite good for that process. But all in all, it's about expanding the knowledge, increasing the quality of the code, but nothing new on the table, right? Beyond these indicators, I wanted to bring an example. If you move to the next slide, so this is the Zen community. Zen they use mailing lists for the code review, and they do certain things. So what you can see in the x-axis in the chart are basically the patches per patch series. So basically, the more you move to the right, the more complex, the more emails the mailing list will receive, and so on. And then on the left, on the y-axis, what you have is basically days to merge. So basically, the time to merge that specific patch series. So moving forward to the next slide, what we can see is the more to the right we move, the more complexity, the more time. And then when we were discussing with Lars, that was the community manager of the Zen community, he had the problem. He claimed to us, we are too noisy. We are having too many emails, the code review process is decaying, but we don't know why this is happening, why this is moving forward. We don't have data, so we need data. And basically, it happens that discussions takes time. Friction happens when there are people, participating with people. What we realize is basically if you want to merge or fix a code review patch series of one patch, it takes 1 unit of time. This is linear growth up to approximately 20. After 20, basically, patch series bigger than 20 patches, the time to review was basically exponential. Okay, so now we have something that could impact software development velocity, specifically in the same community. So then their clear recommendation was, okay, whatever is coming to the community bigger than 20 patches, please split this into something smaller, if possible. So these are some examples of red traffic lights that you can see. There are some pointers of things that are basically failing. There are some references that we are providing at the same time and at the end of the presentation. So let's go to the takeaways.
All right, so in 15 minutes, what we are trying to do here is tell you, hey, it is time to start putting some data analytics and some engineering thought into how the process of creating software works, and putting data on it, all right? To support what you already know, right? To support what the experts think, what the experts are telling you, especially at scale. So that's the first idea. The second idea is that we have great frameworks out there that provide us a lot of information, a lot of insights, and point us in several directions that are good, that make correlations. All of them tell us that we have to measure, which is a good thing, but there are limitations, especially in this kind of environment. So we are exploring in some ways here. There is a lot of academia in some of our environments, although we have a great good start with the frameworks. Then this idea of a journey, right? From not investing a lot of effort into collecting the data, processing the data at scale from the different sources, to having business intelligence, just like a company would have in any other area of the business. It's a long journey, right? And we need to learn a lot about in this area. But the message is, the sooner you start, the better. And there are plenty of examples. We just put some, but we have already plenty of examples, and you can read out there are plenty of examples where data confirms notions of ideas that we have in what are the good practices and what are not good practices, and how you can manage certain situations when you have a lot of teams, and how you should deploy, what concepts, how you can follow better flow, how you can increase your flow. There are out there movements like continuous delivery, things like that, and we are trying to confirm those with data, right? So there is already a lot of things we can take on this environment, these embedded environments. And finally, at the end of the day, what we are looking for is getting a holistic view of what's going on, from design to maintenance, and from business requirements down to code. That's what we want, right? Those are the two axes in which we are trying to move when we think about hundreds of people producing software and that goes into hardware, right, to the market. So we are trying to provide a holistic view based on data to support the view that your managers, that your tech leads, that your developers, your teams provide you. Yeah,
this might be a naive comment perhaps to end the talk, but we've seen over the years that people, when they say, hey, we have metrics, everything is fixed. No, so this is just the first step of the journey. So just think of metrics as another tool to make informed decisions. So that's it.
Yeah, we put some reference about the work we do, and that's about it. Thank you for coming.
Questions?
If you have any question, that is your time. No, this is usual.
Yeah. Based on the examples that you gave, I have the impression that you mostly apply this in bigger companies with big teams. Do you think it also scales down to small teams, like maximum 10 people involved in a product?
The answer is partly yes. So when you have less teams, you have, I mean, this is all about getting some control of what's happening and basically defining if what you think, the actions that you're taking to improve, if you are actually improving at end-to-end. Mostly what happens is that you have the feeling that you improve or you clearly improve with certain action in your area of the entire process, but you are creating a problem elsewhere, right? When you have 10 people, it's easy to detect if that is going on, right? So the only metrics you probably need are metrics that tells you end-to-end how things are going. You don't need to go very deep. So there are some basic metrics that are always good because everybody gets the same idea of improvement. But you are correct. When we think about analysis and deep analysis, this is mostly about organizations that for different reasons, even because sometimes because they are big and sometimes because they don't create 100% of the product, they rely on other companies, or they are bringing a lot of open source, for example, right? A significant amount of open source into a product. They don't have a clear end-to-end view. And by asking the people one-on-one, either that's very tedious or they get mismatched or different kind of messages, and they cannot create this idea. So for example, imagine a company that, okay, I'm going to increase by 2 million my software development budget by hiring 50 more developers. And then suddenly you don't see that you are getting faster time to market, right? And the only thing that you get from the engineering department is we need more developers. Right? It's a clear message. We need to increase, right? And so as from the manager perspective, no, hold on. If you want to increase, it's because you need to justify that. That's a typical conversation at that level. And other levels are like, oh, I'm improving. And then you are suddenly creating a bottleneck, but you don't know it. Or you are increasing the variability of your system, you don't know it. So the scale is very, very important. But still, there are certain basic metrics that I think a group of 10 developers can have flow metrics, for instance, and also pay attention to dependencies and make sure that there is that you can actually, that what is happening in the code matches what you have on your tickets. Imagine that you're using stories without having to put somebody just specifically to make sure that both realities match, right? Some metrics that allow you to have some connection between stories and money. It doesn't have to be a direct connection, but some connection, right? So it helps you to take decisions basically on prioritization. Are we going to do this first or the other one first, right? Imagine that the customer wants both, or you don't know exactly how the market are going to react. Then you can make those decisions based on costs, right? So, yeah, but our main focus nowadays is definitely big corporations, yes.
I'll bring another example, unless there's another question. Okay, I'll go with example. So I remember having a conversation around these metrics in a small team of data scientists. So it's not exactly software developers. So their background was a bit different than software engineers. Basically, those kind of metrics were kind of useful to show like a mirror. So yeah, we are following good practices, we are proceeding in these ways, etc., etc. But then suddenly everyone agrees on a certain way of proceeding, and then you show the mirror and say, well, that's not true. What is this big commit of, I know, hundreds and hundreds of lines? This doesn't make sense. Oh, well, this is something related to a data set that we need to upload. Okay. But we agree that this is not the right way. Okay, yes, you're right. So then data is, or having metrics is a way to reinforce good practices, and so that we are kind of moving forward into the way of working, we can say, that we agreed, whatever it is. And that has been quite useful, at least at the small teams level, we can say. Okay.
Do we have 1 minute for another example? Okay, no. Okay.
So we are done.
Thank you.
Thank you.